Hi all, this is Dinesh Akalan. Today I am going to explain about fundamentals of wireless networks. Actually, wireless networks have been a crucial part of network communication in last few decades. This new technology enabling multimedia communication between people and devices from any location. Also, it brings fundamental changes to data networking and telecommunication. It has made the network portable because of digital modulation, adaptive modulation, information compression, wireless access and multiplexing. It supports existing applications such as sensor network, smart homes, telemedicine, and automated highways. Early days, wireless technology used for military, emergency services, and law enforcement organizations. As a society moved towards information sensitivity, the need to have information accessible at any time and anywhere takes on a new dimension. With the rapid growth of mobile telephony and networks, the vision of a mobile information society is slowly become a reality. Nowadays, it is common to see people communicating via their mobile phones and devices. Protocols. Protocols are very important factor communication between two entities. Protocols provide a standard set of rules to follow in between devices to communicate with each other. Protocols define what is communicated, how it is communicated, and when it is communicated. There are three elements in the protocols. They are syntax, semantics, and timing. Standards. Using standards, different vendors can work together. This will lead customer to find standard devices on low budget. As a result of this will encourage the user to use these technology more often. There are many authorization standard creation organizations such as IEEE, ISO. Wireless communication standards. In wireless communication standards, we can classify it into four individual categories based on their specific application and transmission rate. Under personal area network, we have IEEE 802.15 for the Bluetooth. Under local area network, we have IEEE 802.11 for the wireless LAN. Metropolitan area network, IEEE 802.16 for the wireless MAN. And wide area network, we have IEEE 802.20. IEEE standards in wireless communication. 802.11 standard is defined through several specifications of LANs. It defines an over-the-air interface between a wireless client and base station or base between two wireless clients. 802.11 pertains to wireless LANs and provide 1 to 2 Mbps. 802.11a is extension to 802.11 that pertains to wireless LAN and goes as fast as 54 Mbps. 802.11b is an Wi-Fi extension to 802.11 that pertains to wireless LANs and yields a connection as fast as 11 Mbps. 802.11g pertains to wireless LANs and provide 20 plus Mbps in 2.4 GHz band. ISO OSI 7 layers. Layer 1 physical layer. Transmits raw bit stream over the physical medium. Layer 2 is data link layer. This is responsible for the format of data on the network. Layer 3 would be the network layer, decide which physical path the data will take. Layer 4, transport layer, transmit data using transmission protocol including TCP and UDP. In session layer, maintain connections and it is responsible for the controlling ports and sessions. In the sixth layer, presentation layer, ensure that the data is usable format and is where data encryption occurs. The last layer would be the application layer. human-computer interaction layer where application can access the network services. TCP/IP protocol suite. Not like ISO/OSI 7 layers, in TCP/IP protocol suite we have 4 layers. We have network layer, internet layer, transport layer and application layer. In application layer allows users to access the network resources. In transport layer, control the reliability of the link. In internet layer, send packets from any network. And the last layer would be the network layer. It's define details of how data should be sent using the network. Signal. Signal is an important factor in data communication. When we want to transmit voice, we need to convert natural voice into electrical signals. It is very important to have electrical signal when we transmit data to long distance destination. Signals can be divided into 2 categories. Analog signal, which we call natural signals, and digital signals. There are 3 characteristics that separate one sign from another. They are amplitude, frequency and phase. Amplitude specifies the maximum distance between the horizontal axis and the vertical version of the waveform. Frequency tells us how quickly the sign completes full cycle. This important characteristic influences the maximum rate at which a sign signal can transmit information. Phase. Phase refers to horizontal portion of waveform with respect to one cycle. Impairments of transmission media. Signal travel through transmission media which are not perfect. This imperfection causes signal impairment. This means that the signal at the beginning of the medium is not at the same end of the medium. What is sent is not what is received. There are 3 causes for this impairment. They are attenuation, distortion and noise. Attenuation. Attenuation means loss of energy. When single or composite signal travel through a medium, it loses some of its energy in overcoming the resistance of the medium. That is why wire carrying electrical signals gets warm. If not, it's hot. After a while, some of electrical energy in the signal is converted to heat. To compensate for this loss, amplifiers are used to amplify the signal. Distortion. Distortion means that the signal change its form or shape. Distortion can occur in composite signal made of different frequencies. Each signal component has its own propagation speed. Differences in delay may create a difference in phase if the delay is not the same as the period of duration. In other words, signal components at the receiver have phase difference from what they had at the sender. The shape of the composite signal is therefore not the same. Next one is noise. Noise is another cause of impairment. There are several types of noise such as terminal noise, induced noise, crosstalk and impulse noise or may corrupted signal. Terminal noise is a random motion of electrons in a wire which create an extra signal not originally set by transmitter. Induced noise comes from sources such as motors and appliances. These devices act as a sending antenna and the transmission media act as a receiving antenna. Crosstalk is the effect of one wire on other wire. One wire acts as a sending antenna and the other wire acts as the receiving antenna. Okay. Next one is we need to consider is latency. Latency defines how long it takes to complete message delivered to the destination. So as a formula, we can get latency equal propagation time plus transmission time plus queuing time and processing delay. Pulse code modulation. Pulse code modulation is a process of digital modulation. When we need to transmit data to long distance, we mix data signal with high frequency signal with no data. The message signal is the signal which is being transmitted for the communication, and the carrier signal is the high frequency signal which has no data but is used for long distance transmission. There are many modulation techniques which are classified according to the type of modulation employed. Of them all, the digital modulation technique used is pulse code modulation. As you can see in the picture, in upper part we can see sine wave input. After the digital modulation, we can see the PCM output. Multiplexing. Multiple signals can be combined and transmitted to space. This method we call multiplexing. Multiplexing divided into different categories: FDM, TDM, OFDM. The FDM is used in telephone companies in 20th century in long distance connection for multiplexing number of voice signals using systems like coaxial cable. For small distance, low-cost cables were utilized for different systems such as Bell system. However, they don't let huge bandwidths. This is the analog multiplexing used to unite analog signals. This type of multiplexing is used when a link's bandwidth is better than the united bandwidth of the transmitted signal. Time division multiplexing. Time division multiplexing is one kind of method for transmitting a signal over channel of communication with separating the time edge into slots. Like signal slots is used for each message signal. Orthogonal frequency division multiplexing. Orthogonal frequency division multiplexing is a schema that was introduced by Robert W. Chan of Bell Labs in 1996. In OFDM, multiple closed space orthogonal subcarrier signals with overlapping spectra are transmitted to carry data into parallel. Bandwidth of a signal. Bandwidth is the difference between the upper and lower frequencies in continuous band of frequencies. It is typically measured in hertz and, depending on the context, may specially refer to passband bandwidth or baseband bandwidth. Modulation. Modulation is the process of converting data into electrical signals optimized for transmission. Modulation techniques are roughly divided into four types. They are analog modulation, digital modulation, pulse modulation, and spread spectrum method. As you see in the image, so according to modulation methods, we can divide the modulation like analog modulation, digital modulation, pulse modulation, spread spectrum. So under analog modulation, we have amplitude modulation, frequency modulation, phase modulation. Under digital modulation, we have single carrier modulation, multi-carrier modulation. Under single carrier, we have ASK, FSK, PSK, and QA. Under multi-carrier modulation, we have OFDM. Data word and code word. In data communication, when we send the data between entities, if destination receives the exact data bit transmitted from the source, this is we call data word. If extra data added to the detect errors to the data word, then we call it code word. Type of coding. We have two categories of type of codings. First one is block coding and second one is convolution coding. In block coding, frame divided into small chunks and redundant bit. Through this redundant bit, we identify the errors. This is we call error detection. According to code word receiver gets, receiver decide whether there is an error or not. If there is an error, receiver will correct the error. This is called error correction. Error correction can be two methods. First one is backward error correction and second one is forward error correction. Buffers. There are two types of buffers in the data communication. First one is receive buffer. Second one is transmit buffer. Receive buffer. The buffer size of system memory that can be used by adapter for receive packets. Transmit buffer. The buffer size of the system memory that can be used by the adapter for sending packets. Flow control. As a result of error control, receive the buffer and the transmit buffer can be overflow. To avoid this situation, we need to control over the data transmit. This is we call flow control. In wide area network, error control and flow control need to do automatically. To have this, we need to have a protocol. Currently, we use protocol HDLC, High Level Data Link Protocol. High Level Data Link Protocol is a group of communication protocol of the data link layer for the transmitting data between network points or nodes. HDLC supports of two types of transfer methods: normal response method, asynchronous balance mode. As you see in the image, normal response method, primary station and secondary station have point-to-point communication. And the latter part of the first image, we can see that primary and secondary stations have multi-point communication. In normal response mode, we can have both options. Asynchronous balance mode. As you can see in the image, first station and second station command and response parallelly. This is we call asynchronous balance mode. Type of HDLC frames. I frame, we call it information frame. Second frame is S frame. So S frame responsible to establishment and termination of the connection. U frame. U frame responsible to session management and control information. Media access control. Media access control is a method to control to access to media. This is very important as it avoids the collision. There are few media access control methods. This layer only used in local area networks. In wide LANs, we use CSMA carrier sense multiple access and CSMA CD. In wireless LANs, we use CSMA CA. CSMA carrier sense multiple access. This method enables us to check the availability media before sending data. In wide area networks, we use CSMA CA to collision avoid. The basic idea behind CSMA CA is that stations should be able to receive while transmitting to detect a collision from different stations. LLC layer. LLC layer responsible for the basic function of the data link layer. Those functions are manage information, error control, and flow control. LLC layers act as an interface between the media access control sublayer and the network layer. IEEE 802.11. The architecture of IEEE 802.11 WLAN designed to support a network where most decision making is distributed to mobile station or devices. In this standard, we have several components. AP, access point, central base station in mobile communication. BSS, basic service set. A basic service set is a group of devices communicating at the physical layer level. ESS, extended service set. Set of all connected BSS. In IEEE 802.11, MAC sublayer uses for collision avoidance before transmission. There are two methods: distribution coordination function, point coordination function. As you can see in the image distribution system, we have access points, we have basic service sets, and we have extended service sets. Set of small VSS, like we call it extended service set. I hope you have gained some knowledge from this video. Thank you very much.